All right, we are on our final question for 2011, question number 6. It says, let f be the function defined by this piecewise function here. A, show that f is continuous at x equals 0. Now remember, we talked about rules of continuity. There's 3 of them. And our first one, we have to say that f of A in this case being 0, we got to make sure that's defined. So, right, there's our first rule. So f of 0 in this case, f of 0 is, if I put 0 into this first equation, notice that it's equal to, for the first one, is going to be 1 minus 2 sine of 0, which gives us 1. That means that is defined, so we're good there. Part B, that means the next part is the limit as x approaches a of f of x exists. Well, in order for a limit to exist, you got to remember that the limit as x approaches a from the left has to equal the limit as x approaches a from the right. So we got to check both of these limits here. So the limit as x approaches 0 from the left, we're going to use that left-hand equation, which would be the 1 minus 2 sine of x. Well, we just said that equals 1 when you plug in 0. And the limit as x goes from 0 to the right, we're going to use the second equation, e to the negative 4x. Well, if we put 0 into that, we also get 1. And so these both equal each other. The limit exists. All right, our last and final part of it. All right, that was our first rule. Here's our second rule, and our third rule is once you find that limit as x approaches a of f of x, it has to equal f of a. And we can see that, yes, f of 0 does in fact equal the limit as x approaches 0 of f of x. So we are good there. We've just shown that it is continuous by doing all 3 parts. If you leave out a part, you will not get the points for this. You do need to make sure you do all 3 parts of this. All right, let's go into part B. For x is not equal to 0, express f prime of x as a piecewise defined function. Find the value of x which f prime of x equals negative 3. Now, piecewise functions, when we take the derivative, we just have to take the derivative of each part. So f prime of x is going to equal, take the derivative of that, well, derivative of 1 is 0. Derivative of negative 2 sine of x is going to be negative 2 cosine of x. And remember, this is for x is less than 0. And notice that I put no equal sign because they said for x is not equal to 0 there. And then the derivative of e to the negative 4x is going to be negative 4 e to the negative 4x. And this is going to be for x is greater than 0. And there's f prime of x. All right, so let's wrap this up here. Find the value for which f prime of x is equal to negative 3. So we're going to set both of these equal to negative 3 and see what happens. Now, negative 2 cosine of x. Well, guess what? That never equals negative 3. So now, let's just focus on the second part. Negative 3 equals negative 4 e to the negative 4x. So if we go ahead and solve for this, we're going to divide by negative 4, which gives us positive 3/4 e to the negative 4x, natural log both sides. And when we do that, that cancels out our e. Natural log of 3/4 equals negative 4x, and divide by negative 4, and we find out that x equals negative 1/4 natural log of 3/4. Now, one thing I'd be careful of, you got to remember that this equation only works when x is greater than 0. So you got to make sure that this is greater than 0, and it is. Okay, you got a negative natural log of 3/4. E is bigger than 3/4, so in order to find a power that's less, that gives you a number less than 3/4, it would also have to be negative. So negative and a negative would make this a positive. So x, the x value that make it equal to negative 3 would be negative 1/4 natural log of 3/4. All right, so that covers part B. And our last part of this problem is find the average value on the interval of negative 1 to 1. All right, well, in order to find that average value, All right, integral over interval, same thing as we always do. Now the only problem with this is you got two parts, so that means we have to do two different integrals. We're going to go integral of -1 to 0 of the 1 minus 2 sine of x dx over 0 minus -1, and we're going to add it to the integral from 0 to 1 of e to the -4x dx over 1 minus 0. And we're going to figure out both of those there. So here, if we do the antiderivative of that, that's going to give us x. Antiderivative of -2 sine of x is positive 2 cosine of x from 0 to -1. All right. Plus, I'm actually going to do these up here together. This would be -1/4 e to the -4x. That's a u substitution problem, from 1 to 0. You know what? I'm going to combine these two intervals to give us 1 minus -1 here. All right. And so if I plug these in, I get 0 plus 2 cosine of 0 minus -1 plus 2 cosine of -1, and then plus -1/4 e to the -4 times 1 minus -1/4 e to the 0 power. And this would all be over 2. And you know what? We're going to leave it just like that because we can't figure out what cosine of -1 is and cosine of 0 is, or we can do cosine of 0, so we might as well do cosine of 0, which is just 1. We can't do cosine of -1 because it's not on our unit circle. Everything else can be left unsimplified, and this is our average value, which finishes up question number 6.